All right, let's go. I would like to finish going over the notes today. That's priority one because of the practice test on Monday. Then any time that's left over, go over last week's test, which I have the brackets up here. Hope you guys grab one when you got your book.
Did we have that yesterday?
No.
I mean, not yesterday. I want to see yesterday. I'm sorry.
So the first thing I would do for these is to try to give you some type of, was that Ferris, you made it?
Hey.
Ferris, second tardy of the year.
Uh-oh.
And if you be in school, you'd be enjoying chocolate right now.
Chocolate? See, chocolate isn't good for me because it gets me on my mind. Why do I have two?
Alright, so
Are we still on week 13? No?
it says prove what type of quadrilateral each figure is.
What packet is it?
It's the same note packet that we've had all week. Like I literally just told you that the first priority is to finish the week's notes. And if we have any extra time, then we'll go over the test from last week. Can you guys hear me at home? Ferris, Yana, can you hear me? Alright. So, hopefully we learned about quadrilaterals a little bit in the first 9 weeks. And the first thing I'm looking at is sets of parallel sides. Okay, after that we can start looking if we need to for congruent sides. We can start looking at the diagonal to see maybe what the diagonals are doing. But the first thing I'm looking at is the parallel sides. And there's nothing that says you have to draw a picture. This can all be done algebraically, but the picture I think just expedites it and makes it hopefully less likely for you to make a mistake. I'm seeing that angles.
Wait. You put the third point on the wrong thing. Is that a candy?
I'll give you one. Sorry, and you know that I think I did that the other day with, I mean, it was hard because we were guessing anyways, but that point that was like, that where you couldn't see it was towards the bottom, I might have gone one far or too far down, but it's not a big deal. I mean, if we were guessing anyways where that point was, so doesn't matter, it was a guess anyways, so like all the work was right, but it probably should have been 1 unit higher. Sorry, is that better, Miranda?
Yeah.
So, first thing I'm looking at is how many sets of parallel sides. And clearly, the top and the bottom ones don't look parallel, but obviously those two are, and I know this because they're both vertical. What do you call a quadrilateral that has one pair of parallel sides? No, you have to have two sets of parallel sides to be parallelogram. A trapezoid, very good. So this looks like it's going to be a trapezoid, but technically they are saying to prove it. So I would prove it, like what formula allows us to show that lines are parallel? Slope formula. So I would just find the slope of, let me see, this is P, Q, R, S. So I would find the slope of PS. And that's when you write it, you're actually doing distance. I don't know, I'm not even sure what the, maybe it would look something like this, where you would put like slope, sub PS, I guess. But that's the slope for PS and the slope of QR. And I have to show that they're the same. Do you guys remember what the slope of a vertical line should be? From algebra 1? What should the slope of any vertical line be?
180.
Oh, that's slope.
Thank you.
Undefined. Undefined. Which means that when you do slope formula, you should get a 0 on the bottom. 0 on the top is 0, 0 on the bottom is undefined. Let's see, that's PS. 1 minus 5, 2 minus 2, that gives you negative 4 over 0, which is undefined. QR is on the top. Ugh. 1 1 minus 7 on the bottom, 7 minus 7, which is negative 6 over 0, which is also always fine. So there you go, I've proven it. I have exactly one set of parallel sides. I don't have any other quadrilateral that has that.
Wow. If I don't write it, you don't write it. So,
Trapezoid, no?
it's not a half.
That's what it's from.
Trapezoid?
Yeah.
Trap. Trap like the music, and then like E and then Zoid.
Yeah, like the music.
Alright, same thing here, negative 5, 0, negative 3, 6, 0, 3, negative 2, 1. My checker over here, my proofreader, can you make sure that I put them on the right place? Looks like I did. Which one is Q?
I did not see any parallel lines.
The one over the top.
The one at the top. Yeah, I don't see any parallel lines here.
What's this called?
That's a good question. I'm just double checking this to make sure I thought of them right. And it looks like I did. Let's name the points. This was P, Q, here, R, S. Well, in order to be a parallelogram, we have to have, In order to be a parallelogram, we have to have two pairs of parallel sides. We clearly don't. And if you can't be a parallelogram, that knocks out rectangle, that knocks out rhombus, and that knocks out square. Because any of those three would have to pass the parallelogram test. Okay? In order to be a kite, you'd have to have sides that are next to each other be the same side. Okay? Which we obviously do not. And in order to be a trapezoid, you'd have to have one pair of parallel sides. So, I mean, it's obviously this is just going to be a quadrilateral. This is just going to be a quadrilateral, just a plain quadrilateral, like nothing more specific. I would do slope formula just to prove it. And in this case, let's just prove it by, let's just do all the slopes to show that really like none of them are going to match. So let's do the slope of PQ. So 0 minus 6, negative 5 plus 3, negative 6 over negative 2 is 3. That one. PQ over here, the slope is going in the positive direction and it's a slope of 3. Okay, now QR, slope of QR. Subtract the y's on top, 3 minus 6, sorry, 6 minus 3. And then negative 3 minus 0. So that's 3 over negative 3, which is negative 1. So this has a slope of 3, this has a slope of negative 1. RS. I can tell from looking at it that's going to be 1, so let's just prove it. 3 minus 1 over 0 plus 2. Change the sign at 2 becomes 2 over 2, which is 1. It looks like PS is going to be 1/3. I'm just counting rise and run. But 0 minus 1 and negative 5 plus 2, which is negative 1 over negative 3, which is positive 1 over 3. Do any of those slopes match? I mean, we do have negative reciprocals with a negative 1 and a 1. The 3 and the negative 3 mean nothing because they have to be negative reciprocals to be perpendicular. But all that tells me is that this here is a right angle. But that doesn't really mean anything. It doesn't mean any type of specific quadrilateral. So the most specific you can look at is when it's calling a quadrilateral. Any questions at home? Economically? Got it. No changes very on it. Negative 2, 8. -2, 1, -6, -7, +12. Alright, so this is definitely looking at least like a parallelogram, possibly gonna be a rectangle. Doesn't look like it's gonna be a rhombus or a square, but we're going in that.
Like, taking the pictures.
No. Dude, you know that this is online, right? Like I'm recording this, so you can go back and watch it and pause it. Okay.
I have short-term memory for it, doesn't matter to me.
You have no memory for what this is actually.
Exactly.
So first thing I'm gonna go for is the slopes again. Like slope is gonna be your ticket. Now, well, let's cross that bridge when we get there. Alright, let's just go with the slopes of each one. And we got, let's name them, -2, 8. So this is, P, Q, R, S. So the slope of PQ is 8 plus 2 over -2 minus 6. That's 10 over -8, which is -4 over 5. You gotta make sure you read your reducing fractions. Positive divided by negative is negative. Slope of QR is -2 plus 6 and 6 minus 1. That's gonna give me 4 over 5. Hey, look at that, negative reciprocal of this side. Keep that in mind. RS is -6 minus 4, 1 plus 7. So you gotta change the -7 to a plus. That gives me -10 over 8. Positive divided by negative is negative. And that gives me -5 over 4. That's also showing me same slope from here, which means if we're looking at slopes, this slope is -5 over 4. This slope is -5 over 4. That means same slope means?
A perpendicular.
No, that same slope is parallel. So those two are parallel.
I knew it was one of them.
Yeah, well, you got the wrong one. Slope of PS is 8 minus 4 over -2 plus 7, and that is 4 over 5. And that works out nicely because now these are 4 over 5. So look, by showing that opposite sides are parallel, we've now proven it's a parallelogram. But within parallelograms, there's more specific types. A rhombus is a parallelogram with it has everything a parallelogram has, but it has one main extra property. All sides congruent. A parallelogram has opposite sides congruent. We haven't shown that, but we have properties that say that. If opposite sides are parallel, they're also going to be congruent. If both sets of opposite sides are parallel, they're also congruent. But now a rhombus, they'd all be congruent. If you want to go try to prove it, go for it. From the picture, it sure doesn't look like it. So I'm not going to waste my time with that. A rectangle is a parallelogram with. If a rhombus is all sides congruent, a rectangle is.
Opposite sides.
No, opposite sides is the parallelogram. All angles congruent. Rhombus, all sides congruent. Rectangle, all angles congruent. Because what are all the angles on a rectangle? 90 degrees. And I already have enough to prove that because the consecutive angles are. Come on, your favorite word, Miranda.
Nope.
Well, they are that's what we said, 90 degrees. But why? What's that comparative word that we use to compare slopes that are perpendicular? 2 words. It starts with negative and ends with reciprocal.
Oh, the reciprocal.
The negative reciprocal, yeah. So really we've just proven that 90, 90, 90, 90, this is a rectangle. Now FYI, if you just love using formulas and you want to use another one to further prove it, the most common one for rectangles is this. You do the distance of the diagonals. You would do distance formula for PR, and you do distance formula for SQ, because if you look at the reference sheet I gave you, what does it say about the diagonals of a rectangle? For rectangle, and go to the diagonal column. What does it say about the diagonals of a? Oh, but they bisect each other on any. They're congruent. That's a good one. Because on any parallelogram, they're gonna bisect each other. Meaning that the midpoint is the same. That just makes it a parallelogram. Yeah. Slope, the y's have to be on top. That's from back in algebra 1. Rise over run. Y on top, x on the bottom. Alright, this is gonna be the last one like this. So negative 5, 6, negative 4, negative 2, 4, negative 1, 3, 7. Okay.
Another technique? What the?
I don't know, that's looking to me more like a square.
Yeah.
It's looking like a square. Let's see if we can prove it.
Oh, yeah, that was a negative.
In order to be a square, you first have to be a parallelogram. So that's the first thing I'm gonna do is go do all the slopes again. I'm gonna see if opposite sides are parallel. Let's see. Let's name them P negative 5, so P, Q, R, S. So the slope of PQ is 6 plus 2. Look, Mohammed, the y's go on top. Negative 5 plus 4. The only real question you could be asking now, but wait, Mr. Merrill, I thought in slope formula, you're supposed to subtract. I am subtracting, but it's just whatever comes second. If I see a negative, I'm changing it to plus. Okay. Now for QR, I'm going to do QR. The R is coming second. Any negative, I'm going to change to plus. Slope of QR. Start with the y's first. Negative 2, that stays the same. But then the negative 1, I change to plus 1. Then negative 4 stays the same. And then minus 4. That gives me the negative 1 over negative 8, which is positive 1 over 8. Oh, that's looking good so far. What do you call those two numbers? Negative reciprocals. So now slope of SR. Slope of SR is negative 1 minus 7, 4 minus 3, negative 8 over 1 is negative 8. That's nice. Also, we've already proven that PQ now, that those two are parallel. And now let's finish up and see what's the slope of PS. PS, I love math.
Oh, I thought it was
You're SQ. Negative 5 minus 3 is negative 1 over negative 8, which is positive 1 over 8. Hip hop array. We've proven that we have a parallelogram. But since all the consecutive sides are negative reciprocals of each other, we've also proven that this is a, no, not yet,
A rectangle.
just a rectangle. So far we've only proven that it's a rectangle. But if we can also prove that it's a rhombus, if you get a rhombus and a rectangle and you put them together, what does that become? It's a square. Now, in order to prove, sadly, I'm sorry for this, but in order to prove that this is going to be a, well, let me see. No, this rectangle proves. I'm trying to see the, can I prove? we do diagonals, check the reference sheet, because on a rhombus, the diagonals are perpendicular. Does it say diagonals are perpendicular on a rhombus?
Yeah,
It does?
yeah.
Mind me, bro.
Look.
Look, the most common way to prove it's a rhombus is to go do distance formula. Now go back to this and just do distance, 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 distance. That's gonna take a while though. Distance formula takes long. If you're trying to save time, okay, another thing you can do now is just go to the diagonals. But like see for the last one, for the rectangle, I told you to do, like we've already proven it's a rectangle, I don't have to do it. But I told you to do distance, because if you look at the diagonals of a rectangle, they're congruent. But I've already proven it's a rectangle. I need to now prove that it's also a rhombus. So a rhombus, those are perpendicular, which means that these two slopes should be what? No, the slopes should be not congruent. Come on, you're favorite. Negative reciprocals. So I would now go do the slopes that I haven't done yet. Slope of PR. I mean, I just think slope formula is quicker, but so let me see, 6 plus 1 on top, the y's go on top, negative 5 minus 4. That's giving me 7 over negative 9, which is negative 7 over 9. In order to be perpendicular, what's the next slope going to have to be?
9/7.
Positive 9 over 7. If I get positive 9 over 7, I've now, well, technically a kite also has perpendicular diagonals, but I've already proven that this is not a kite because the opposite sides are parallel. So like once you already go in the parallelogram category, or I'll draw this again, parallelogram category, now the only other thing it could possibly be is a rhombus or rectangle. And if it happens to pass both tests for rhombus and rectangle, then it's a square. So up to now, I passed this one and I passed this one. If I were to somehow fail this, what would it be? Just a rectangle. But if I end up passing all of them, then what is it? Then it's actually a square. A square is like a hybrid of a rhombus and a rectangle. So let's go do that slope. So we did PR, now let's do SQ. Slope of SQ, looking up here at the S and the Q. So negative 2 minus 7, negative 4 minus 3. That gives me negative 9 over negative 7. Oh no, we got it wrong. No, we didn't. Negative divided by negative is positive. So right in the sense that those would be negative reciprocals, they are. So this is, that's like Sam, a square.
A square? How?
It's nice today. The casual look. Turtleneck. Nice. Did you get in trouble with your OTC for your scarf?
For what?
Did you get in trouble for your scarf?
Yesterday, not today.
Yeah, no, well, no, I didn't see you yesterday, 2 days ago.
Yeah.
You got in trouble?
Oh, yeah.
Alright, this next page is kind of a reference sheet. I'll leave it there for you to go back and look at, but I just think you're gonna understand this better than this partitioning segments. I just think you'll understand it better if I just demonstrate it for you. So I'm gonna skip to the first example. So look, the segment is just AB. Forget about the P right now. But they're saying, hey, if I wanted to split this into a ratio of 1 to 3, where would this point P be? So what they're saying is, okay, if I were to break this in where I would have one piece of it here, and then 1, 2, 3 pieces on this side. Like, break it into equal parts, that's what partition means, break it into equal parts, but only one part is over here, and then, 1, 2, 3 parts over here. Well, that's the case, how many total pieces are there? 4, keep that in mind, okay? So here's what you're gonna do. You have to pick one point as your first point. Assuming that we're going to go in alphabetical order, let's say that this is the first point and this is the second point. Like, think of this as being like the starting line, and then B is the finishing line. Okay? You're going to get the x of the first point. What's the x of the first point?
Negative one.
-1. And then you're gonna add, okay? You're gonna add, and this one has to go in order. You gotta do finish minus start. So we gotta jump to the second x and do that 7 minus the first x, because that's what's gonna give us the distance. That's what's gonna tell us how far these are away from each other on the x. So what is 7 minus -1 and 7 plus 1? And actually, um, 7 times this number up here, whatever number is there, over the total amount. What's 1 plus 3? 4. And that's going to give you the x's. The y's would be, what's the y of the first point? 2. Plus, because you're adding to it, so we want to see how far along on the race we're going to go. We need that total vertical distance. So we would go the second y 8 minus the first y, which is 2, times the partitioning, which is 1 over 4. 7 plus 1 is 8. What's 8 times 1 over 4? This gives you 8. What's 8 times 1? Divided by 4 is 2. 8 divided by 4 is 2. So we have -1 plus 2. That's going to be the x. So the y 8 minus 2 is 6. 6 times 1 over 4. We'll leave it as a decimal. It's 1.5. So that's 2 plus 1.5. So this point P that we were looking for here is going to be at 1, comma 3.5. If we look at the picture, now they had it drawn for us so that we can kind of see if we got it right. And it does appear, even though there's no way to be sure that this is at 3.5, at least I feel better by the fact that it's in between 3 and 4 on the y, and on the x, 1 and 3.5. Here, let's do this last one together. We finally made it to the end. Given these points, what are the coordinates of the point that partition it to a ratio of 3 to 2? Okay? Meaning of? The last one?
No, I said this is the last one.
Yeah, read it together. So, if this is the start of the race, this is the finish of the race, what point along that race would break it up so that two sections are before it and 3 sections come after? Right? If I were to draw a picture, start line, finish line, which point around here would break this before into 2 sections and break what comes after into 3 sections? Meaning, how many sections are there in total? 5. Okay, so let's do the same thing that we just did. We'll call one point the start line. Technically, it doesn't matter which one, but you gotta just stick with it. Whatever you call a starting, you gotta stick to it. I'll just pick P. And I'm gonna say, okay, the x is 2 plus, because I'm gonna start running in the race. I have to add to where I'm going in the race. But now when I subtract, I gotta go the finish line minus the start. So for the x's, the finish line is at -9 minus 2 times, okay, so, and I'm sorry, I did it backwards, so the picture that I just drew, I'm sorry, they said 3 to 2, so they wanted 3 sections to come before and 2 sections to come after. Did I throw anybody off there? I'm sorry, I thought it said 2. We're good?
Just
Okay.
confusing.
So the number that goes on top means, is the 3. I need 3 sections to have gone before, but then the number that goes on the bottom is the total. How many sections are in total?
4.
5. Meaning, where would I be when I am 3/5 done with the race? When I have done 3 out of 5 sections, where would I be? That's what that fraction means. Comma. Now let's start with the y's. What's the y of the start line? -1. Plus, because I need to start racing. Jump to the second point. That y minus the first y, which is -6 plus 1. Change the sign of that 1 because it's minus, yeah. The only one that matters is in here. Okay? This has to be x2 minus x1. This has to be y2 minus y1. I have this page that I didn't go really over, but if you want to go read it on your own, they explain it to you. They give you the formula. Here's the starting line. Now they just wrote it backwards. They wrote the fraction first and then they wrote time. But look, x2 minus x1, y2 minus y1. So -6 plus 1, and then times that same 3/5. Where would I be on the y when I was 3/5 finished with the race? Okay, let's do some math. -9 minus 2 is -11. -11 times 3 is -33 divided by 5 is -6.6. Can you guys check my math here? So do -11 times 3 divided by 5. Times 3 and then divide by 5. So, and then it's minus, because this was a negative times a positive, so it's minus. Comma. -6 plus 1 is -5. Times 3 is -15. Divided by 5 is -3, so -1 minus 3. If you're confused, this 2 just dropped. This -6.6 just came, I just did it mentally. Do it on the calculator if you want, it came from that. This -1 just dropped. This -3 just came from doing this. So you're not confused. 2 minus 6.6 is a -4 -4.6. Comma, -4. That's where I would have put. If you want it to make more sense to you, draw it on the graph, and you'll see that it actually looks like from where these points are, that I actually would have started the race up here and finished it somewhere down here, and this tells me one side's gone. No. 1 section, 2 sections, 3 sections. When I finish 3/5 of the race, at this point that's along the line there would be -4.6, -4. Yeah, and you know what? Oh, is it there? Oh, because we were looking at the multiple choice. Well, the -4 being, it's got to be this. Put -23. Did I do the math wrong? No, that was wrong. -23/5 is. Oh, because I'm looking at the multiple choice. I'm looking at the multiple choice. Let me see. 2 plus -9 minus 2. I did that right. They go backwards and do it the other way? The segment PQ that partitions PQ into 3/5. -11. I'll do it my way. My way is right. I don't know why this is so off. Let me, -1, which is correct. -6 plus 1 that's going to be -5. Yeah. -1 minus 3 is -4. 2 minus 6.6. Oh, okay, no, I think I might be right. Okay, it might still be good. What? Because I'm looking at this -6.6 number. What's negative 23 over 5? Yeah, is it negative 4.6? I'm sorry, I was looking at the negative 6.6. The answer was negative 4.6.
Yeah.
That should be good. Okay, so perfect. There you go. The answer's there. Any questions there? Alright, let's see how much of the test we can go over. And then whatever I don't finish today, I'll finish on Tuesday as part of the review for the other